So again, as I stated before, we will be talking about permutations. Now, permutations is a part of probability, and just a quick review to remind us of what probability is. I mean, I'm sure you all know what it is. We use it all the time, even though we don't think we do, because people always say you can't apply the math you learn in school to what you experience every day, but you actually can, especially with probability. I feel like probability is one of those that you can apply all the time. For example, as this picture shows, how many of you have played Twister and you spin the spinner, and what are your odds of landing on left, and a lot on left foot, or what are your odds of landing on red? You know, when you roll a die, what are the chances that you'll roll an even number so you get those doubles in Monopoly? Or when you flip a coin, what are your chances that it'll land on heads? What are your chances that it'll land on tails? And even the deck of cards, when you're trying to figure out what your chances are of pulling out an ace. This is all probability. We see this all the time. We just don't think about how it's mathematical and how it's something we learn in school. So again, we're talking about permutations. And if you look at these pictures, it's showing you that different ways in which you can arrange something. So for instance, if you look at the first picture, this one right here, we see that somebody's won first, second, and third place, right? So the important thing to remember about permutations is that order matters. So again, if we look at this picture, or even this picture, we're seeing that the order would matter. In the first picture, once somebody wins first place, no one else can take that person's spot, right? Then you get second and third. If you're trying to unlock a lock, if you put the combination matters, right? So even if, say, your combination is 5, 4, 3, 2, 1, that first number has to be 5. If you put 3, even though it's a part of your lock combination, it's not going to open it for you. So, right? So again, order matters. Now, just a quick reminder about factorials. Factorials are the product of all the integers from n down to 1. So as I show the example here, 5 factorial, I'm not just excited about math, even though I do love math. Factorial is that what looks like an exclamation point. So again, it's the product of all the integers from n down to 1. So as you can see here, you would multiply 5 times 4 times 3 times 2 times 1. So it would be the product of all these numbers. That's what this factorial means. And it's part of our equations or formulas for permutations, and when we'll be learning about combinations tomorrow. So you just need to know that. Now, as I stated before, with permutation, order matters. That is our key phrase to remember with permutations. It'll be easier to figure out our problems later if you remember that order matters, especially after we learn combinations, which we will be doing tomorrow. But permutations pretty much means it's a group of people or objects arranged in a certain order. And I highlighted certain because, again, order matters. Now, the number of permutations of n distinct objects taken r at a time is given by the following formula. So this is just the notation to put it. It's written different ways, but this is the way I like to write it. So it would be then n factorial over n minus r factorial. Remember, parentheses are important because when you try to push this into your calculator, if you don't input it correctly or with the parentheses, it might give you a different number, and we don't want that. So let's break down the formula just so you can see. So again, the n, is the set size, so the total number of items in the sample. The r stands for your subset size, so it's the number of items to be selected from the sample. Now, we're going to do examples, so you'll see this into practice, but for now, just remember, so because you're going to need to figure out what to plug in for your letters, so for your n or your r. So let's take a look at an example. So if there are 10 finalists in a figure skating competition, how many ways can gold, silver, and bronze medals be awarded? So first of all, let's figure out our n. That is our, going back to here, it's our set size. So if we carefully read our example, there are 10 finalists in the figure skating competition. How many ways can gold, silver, and bronze medals be awarded? We know that our set size would be 10, right? Because there are 10 finalists in order. So we plug in 10 for n. And now we need r, our second variable of the equation. And again, if we look back here, r is the subset size. So again, rereading our problem, we can see that our subset size would refer to gold, silver, and bronze medals, because those are what is being awarded, to the 10 finalists. And gold, silver, and bronze obviously add up to 3, as I have written here. So our r would be 3. So if you plug all this in, we then get 10 factorial over 10 minus 3 factorial. Again, pay attention to the parentheses, okay? Because it's important. If you don't, you get a different answer, and we don't want that. So again, plug back in. We get 10 factorial over 7 factorial, right? We subtract 3 from 10. Then, if we expand it, now you'll be able to do this in your calculators. I just want to show you the expansion so you can see how you break it down. I don't want you to just plug this into the calculator and that's it. No, I want you to break it down. Now, obviously, it's more convenient if you use a calculator later, but I want you to see it broken down. So again, 10 factorial becomes 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, by order, we know our rules. These, excuse me, sorry, I lost my mouse. These all can cancel out, right? So then, if we cancel all these numbers out, we're left with 10 times 9 times 8. And we can calculate that, and we get 720 ways in which gold, silver, and bronze medals can be awarded to those 10 finalists. Now, just in case, let's do another example. The newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover the stories? Again, we have our same formula, P of n of r, equals n factorial over n minus r factorial. So here, our set size would be these 9 reporters, right? That's how many total we have. So we plug that in for n, and our r would be 4, right? Because they're covering 4 different stories. So then we plug that in for r. So then we get the permutation of 9 and 4. So we get 9 factorial over 9 minus 4 factorial, which gives us 9 factorial over 5 factorial. Again, pulling it apart and expanding it, we get the product of 9 all the way down to 1 over the product of 5 all the way down to 1. And again, all these cancel out, and we're left with 9 times 8 times 7 times 6, which calculates to 3,024 ways in which those reporters can be assigned to cover the stories. Now, what this equation we learned was permutations without repetition. Now, permutations with repetition has a different formula, which is the number of permutations of n objects of which p are alike and q are alike is n factorial over p factorial q factorial. Simple equation we just need to memorize. Again, an example. How many different ways can the letters of the word Mississippi be arranged? Now, first thing we need to figure out, is our n, right? And again, that's our set size. So our set size for the word Mississippi would be how many letters we have in total. So we count it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So our n becomes 11. Now we need to look at what repeats. So obviously Mississippi has a lot of repeating letters. So we look at the number of i's, we count 4, right? 1, 2, 3, 4. Look at our number of s's, again there's 4, and then our total number of p's, there's 2, right? And then m, there's only 1. We don't need to worry about that because it won't affect our answer. So again, if we plug all this into our formula, n factorial over p factorial q factorial, we get our n, which is 11 factorial, over everything that repeats, right? So we have 4 factorial, and 2 factorial. The first 4 factorial stands for the number of i's, the second 4 factorial stands for the number of s's, and the 2 factorial stands for the number of p's, right? Because all that repeats, we use this formula. So again, just like we did with our earlier examples, we expanded to calculate for our answer. Again, 11 times 10 times 9 times 8 times 7 times 6 times 4 times 3, times 2 times 1, all over product of 4 factorial, and 2 factorial. Again, we can get rid of some of this, which I know I don't have to break down that for you. I know you know how to do some math, some basic math. We input it into our calculator, we get 1,663,200 over 48, which gives us 34,650 ways in which the letters of Mississippi can be arranged. That is a lot of ways. Now, let's do another example just in case. So our second example reads, how many different 6-digit numerals can be written using all of the following 6 digits? So they give us 4, 4, 5, 5, 5, and the 7. So again, our total number of numbers, which is our n, was 6, right? We have 6 numbers in total. Now we look at what repeats. We have 2 4s and 3 5s. So if we plug it into our n factorial over p factorial q factorial, which is our formula for permutations with repetition, we get 6 factorial, again, our set size, over what repeats, 3 factorial and 2 factorial. The 3 stands for the number of 5s, the 2 stands for the number of 4s. Again, we figure this out. This can cancel out. We're left with 120 over 2, which gives us 60 ways in which we can write the following 6 digits. Different ways in which we can write the 6 digits. Now again, like as I stated earlier, after we do a little more practice with this, you're going to create a poster which includes your name and a calculation of the different ways you can rearrange the letters of your name. But let's practice a little more just in case.